Hi everyone, what's up? Good morning. All good? Great. Today we will be solving the question minimum common value. Okay, so let's see what is this question. Given two integer arrays nums1 and nums2 sorted in non-decreasing order, return the minimum integer common to both arrays. Okay, if there is no common integer among us nums1 and nums2, return -1. So we are given with two integer arrays nums1 and nums2, which is sorted in non-decreasing order. It means increasing order. Okay, so we need to return the smallest common integer between both these arrays. And if there doesn't exist any common integer, then we just need to return -1. Note that an integer is said to be common to nums1 and nums2 if both arrays have at least one occurrence of that integer. Yeah, okay. So let's see how we can solve it. So we need to find the smallest integer which occurs in both these arrays. Okay, so how we can find it? Like we need to iterate through this and we need to iterate through this. Let's say it have n elements and it have m elements. Okay. So if we check for 1, does 1 exist in this? No. Does 2 exist in this? No. So for each element of nums1, we can check for nums2 whether it exists in this or not. Okay, so but it's then time complexity will become big of n into m. It means, or we can say that n square. And here you can say the constraint says nums1 dot length and nums2 dot length is 10 to power 5. So obviously it will not going to work. Okay. So now we need to think about something else. As for each element of nums1, let's say as for each element of nums2, we need to search for nums1, whether it exists in nums1 or not. Okay. So can we reduce it to something? Like, if we don't need to iterate the complete nums1 for finding 2 in this array. Yeah, as you are giving that, it is sorted in increasing order. So, whenever an array is sorted and we need to search anything, then what we apply? We apply binary search. So, for finding 2 in nums1, we can apply binary search. Okay, then what will its complexity will become? Its complexity will become big of m for iterating this array and log n for finding that element in nums1. Okay, this will be the complexity for binary search. Okay, and then what will be its space complexity? Big of 1 as we are not using any extra space. Okay, cool. Then this will be the complexity for binary search approach. Okay. But this m log n is not looking that much good. Can we reduce it to something linear time complexity? Okay, let's see how we can do that. So we need to find whether 2 exists in nums1 or not. So can we store the elements of nums1 somewhere else and then find in that whether the element of nums2 exists in that or not? Yeah, we can do that. How? We can do that by storing the elements of nums1 in a hash map or hash shell. So first, initially we will store all the elements of nums1 in a hash map and then I create nums2 to find whether that element exists in that nums1 or nums2. Sorry, whether that element exists in that map or not. If yes, then we can simply return that element because it is sorted in increasing order. So whenever we encounter first element which exists in the map, at that point only we just need to return true. Okay, let's see. So here we have created a map and we are simply storing all the elements of nums1 in that map and then finding and then iterating the nums2 array and then finding if that element exists in map. If yes, then we are simply returning that element. Then we don't need to iterate the further elements as we need to return the minimum integer. And if not so, then at the end we are returning minus. Cool. So then what will be the time complexity of this approach? As we need to iterate nums1 first, so it will be n, and as we need to iterate then nums2, then its time complexity will be big of n plus m, and its space complexity space complexity will be big of n, as we are storing all the elements in a map. Okay, now what we can do? Yeah, we have converted the time complexity to linear time complexity. But now we can't reduce the time complexity. We can't do this question in big of one. So now the question comes, can we reduce this space complexity? Okay, so let's think of this. If we can reduce its space complexity. So we need to find the first element, which is common to both of these arrays. By first, because they are sorted in increasing order. So first element will be the smallest element. Okay, so here if we iterate both the arrays simultaneously, and whenever we encounter first element as common to both of them, and at that point we just need to return true. So whenever we are iterating two arrays simultaneously, then what it becomes? Two pointer. Okay, so let's say I will start two pointer. I from here and j from here. Okay, just a sec. I from here and j here. Okay, so let's say initially I is equals to 0 and j is equals to 0. Okay, so are they equal? No. And which is small? The element at ith index is smaller than this. So we will increment I. Okay, so when now I is pointing to this. If now whether they are equal or not, yeah, at this point they are equal. So we will just return 2 here. But what if they are not equal? Let's say here it was 3. Okay, so now j is pointing to 0, I is pointing to 1. Which element is the smaller? This one, 2. So we will simply increment our I. Now I will be pointing to this one. Now if they match, then yeah, we will return 2 and it will return that element which is 3. So here what we can see, if the element in both the pointers are equal, then we will return that element. Otherwise, the pointer which is pointing to a smaller element will be incremented. That's it. Simple. And at the end, if we didn't encounter any element which are equal, then we will return minus. Okay, so now let's discuss its time and space complexity. Its time complexity is also remains big of n plus m, as we are including both the arrays. But now we are not using any extra space. So its space complexity will be reduced to big of 1. Okay, so let's see how we can code this approach. So first, I am storing the size of both the arrays as n and m. Now I need to initialize two pointers, I is equals to 0 and j equals to 0. And these two pointers will go till I is less than n and then j is less than n. As any of these two pointers will finish, then we will come out of this loop. Now if nums1 of I equals to nums2 of j, then we will simply return that element. Yeah, great. But otherwise, if nums1 of I is less than nums2 of j, then we will increment I, else we will increment j. If we have not encountered any element which are equal to both the arrays, which are common to both the arrays, then we will return minus 1 pn. Simple. Just try like this. Yeah, it's working fine. Just try submitting this. Yeah, cool. It's working fine. So now this was the most optimized approach for this question. I hope you get it. If you still have any doubts, you can post in the comment section. I will surely try to answer them. Till then, bye bye guys. See you in the next video. Bye bye.